monitoring uptime on the Nectar Research Cloud. So I thought I'd start with a little bit of an architecture overview. So how many of you operate OpenStack clouds? And how many of you are running services or infrastructure? Yeah, okay. So well, a lot of you I work with, so that doesn't really count. But so the Nectar Research Cloud, we've got this is like a really high level, but we've got a central core where we run our top level APIs, and then outside of that, we've got 8 sites. Each site hosts the compute for the cloud. This slide does need updating, but within each site, you've got you'll have compute, you'll have some storage, and some services there that connect it to the rest of the cloud. Next slide. This is an overview of our control plane. On the right there, we've got a laptop there that indicates that users will connect to the dashboard or to OpenStack APIs through the load balancer. The load balancer then forwards those requests to our APIs. We've separated them into Tier 1 and Tier 2. Tier 1 is services like Nova, Keystone, Glance, the kind of really major services. The Tier 2 is kind of like your Heat, Murano, less important services. Depends who you talk to, I guess. So the next level is you've got your RabbitMQ cluster. We've got MySQL database running Galera, and in the bottom here we've got our service or engine kind of level where you'd have sort of, for us we've got Nova Cells. That's kind of the level where the resources get created. So there's a lot of levels here. There's a lot of places where things can fail and go wrong. So our strategy is we try and test everything. Because there's so much complexity in OpenStack, and those who run OpenStack clouds and even the OpenStack Foundation recognise that there is a lot of complexity within OpenStack. You really need to try and test all the components so that when you do have failures, you can more quickly pinpoint the problem and limit your downtime. So we start with the APIs and the dashboard. So they're relatively simple to check. You've got your tests like checking the TCP port is open. You've got your services, right? So you want to make sure that you've got your processes are running. You've got the right number of processes. You've got your processes for Nova and your Keystone, and all those critical pieces that are required to make it all work. Another level of your testing will be that your existing resources are happy, right? So you've got instances that are already created on your cloud, right? The top level APIs could have an issue or they could be down, but that shouldn't really affect your already running instances. So we really need to start testing all these kind of layers of the system to have like total uptime or having it totally working. We also need to test that new resources can be created. So you could have your APIs up and running, but there could be an issue with your RabbitMQ server, like we had this morning. In those circumstances, your APIs, they might be returning correct results. You can say, boot me a server. It'll say, all right, I'll go and do that, and then it will come to Rabbit. Rabbit won't be running correctly, and things will just stop. So the users might not even realise what's going on there. They might be successfully submitting API requests. APIs might be saying, yeah, everything's fine, but then in the back end, actually nothing's happening. And then we've got, we have, 7 or 8 sites. We have to test all the components at all of those sites as well. If one of those sites is down, then users might have a bad experience, but they might not if they're lucky enough to get scheduled to a site that is working, right? So it's not always obvious that you have a problem and where that problem is. So I talked a little bit about this before, but at the kind of top level, we've got our control plane hosts. Some of the tools that we use for this, Nagios and Ganglia, your standard ping test. I mean, that's great for establishing that you've got at least network connectivity. SSH, we need SSH to get in as system administrators, so it's a great thing to test. NTP is critical because if your time servers, at the time when your hosts are out, then you can have all sorts of strange and unusual problems. File system, when the disk fills up, things fall over. We have a test for uptime. If you have a virtual machine hang for some reason and gets rebooted, we want to make sure that we know that if that virtual machine has been rebooted and we haven't been aware of that we get an alert to let us know that that's happened. So we have an alert that triggers if the machine has been restarted in the last 30 minutes. And also Puppet. We use Puppet to provision all our infrastructure. It's a fantastic tool, but we need to make sure that it's continuously running, and when it does run, that there are no resource failures for it. Likewise with Ganglia gives us a different perspective. Ganglia gives us a perspective of the metrics more so than whether something's okay or critical. Ganglia will show us sort of CPU and memory utilisation, which are really useful metrics when you're looking for, trends. If you've got a service that's misbehaving, you can look at CPU, memory, even network and disk I/O to kind of analyse, if there is a trend of memory being used, memory ballooning or something else, something we don't know about. It's a good place to go and check to see, what are the trends like? Is it growing? Is it shrinking? To give you a better understanding of maybe what your infrastructure is doing. So the services on the control plane. We talked a little bit about sort of your Nova, your Keystone. So we've got Nagios running on those with the NRPE daemon. That lets us run specific checks on the host itself. So we can test that the endpoint's there, it's running, and there's a process running. There's the correct number of processes running. If we have workers set to 8, we want to make sure that there's 8 processes running. We've also enabled the Oslo middleware health check. This is, for some reason, this hasn't been pushed as enabled by default in OpenStack, but the Oslo middleware health check allows us to define a health check endpoint of the service. So we can call /health check on any of our API endpoints, and it'll return an OK if it's OK. Otherwise, it'll return something else, depending on the state of the service. This is really useful for us, especially with the load balancers. We can use this check because it's low impact on the services, so we can check it very frequently, like every couple of seconds from the load balancer, to make sure that the service is up and running, so that if we do have an issue with one particular API host, the load balancer can pull it out of the pool instantly, and so any impact is mitigated, and we can fail fast, basically, and let the user get on with what they're doing with against another API host. We also have some more complex tests. We use a lot of the OpenStack the libraries, so that we can we can script up things based on those clients. So, for example, we've got a check where we just call a Keystone library and say, here's some credentials, give me a token. Right? It's like very simple, but it gives us confidence that Keystone is working correctly because we're doing a legitimate call like a user would, or like you get through the dashboard if somebody's trying to do some sort of operation. We're really mimicking those kind of steps that the users are doing, so that we've got some confidence that it's working correctly. Likewise for Glance, we have a similar script whereby we call Glance and say, give me all the Ubuntu images, and we want to make sure that it returns a list and it has X number of images like what we expect. There's a lot more work we can do in this space. As we saw this morning in the keynote, there's, I can't remember, they say 20, 50, some astronomical number of OpenStack services now, and we're running quite a lot of them. And we really need to have these kind of complex tests to have the confidence that everything is working correctly. So, another dimension of our testing is testing our environment. We've got a number of availability zones. We want to make sure that each one of them are operating correctly. So some of the things that we identified were causing issues for users were, for example, if the metadata server of that site was down. It's not obvious that it's down, but once you try and launch an instance there, if the metadata service is down, Cloud Init doesn't run. If Cloud Init doesn't run, then the user's SSH key doesn't get put onto the host, and then the user's sitting there scratching their head saying, what's going on? I've launched an instance, says it's okay, but I can't get in. That causes all sorts of frustrations for users. So a really simple way to test that is that we have a canary instance that we run in each availability zone. It's a tiny one, uses one core, very little RAM. And from here, we can use Nagios to ping that instance. That gives us some confidence that the network connectivity between us as the core and the site is working correctly. We occasionally have issues at the data centers of the sites. It's not always obvious what's going on, so at least this gives us some idea that the network is working. And DHCP too. When we went to Neutron, there were some issues with DHCP and failovers and stuff, and if the DHCP server is not running, then new instances that come up can't get an IP, can't get in again. More frustration for the user, or even worse still, if DHCP is down for too long, then the instances that were running can lose their IPs, and then everybody's in trouble. So these are DHCP and metadata. They're very simple shell scripts, and they're just run by the NRPE daemon through Nagios. Ping is a server-side test from Nagios. Really simple, but it's not an exhaustive test, but it's a good indicator that basically things are working. And so it gets more interesting when you really want to test the full experience that the user will have. So I don't know if you've heard of it, but OpenStack has a project called Tempest. And Tempest is it's an integration testing tool. It has a lot of tests. It has a lot of what they call scenarios, and this is an example of one of the scenarios that we run. So we have the Tempest. We have a virtual machine running Tempest. We use a combination of Nagios and Jenkins to run these tests. And so the test is to boot an instance in the same way that a user would. We boot a tiny instance so that it's low impact. We run it fairly regularly, I think about 30 minutes for each site, and it does all the kind of standard things. So fetch a token, we create a key pair. I mean, key pairs aren't created every time by a user, but it's good to test anyway. It'll create security groups and rules, and then it will boot the instance, wait for the instance to come up. It'll ping, make sure that connectivity is there, and then SSH to the instance, and then within the SSH it'll run a really simple script just to make sure that it's, you've got a shell there, it's working, and then it will destroy and clean up all the resources like it was never there. So this is the test that gives us the most confidence. We know that by running this test, if this test passes, we're fairly confident that when a user goes to the dashboard, clicks, I want an instance at this site, that this is the workflow they go through, and by running this test, we know that that's generally going to be fine. So using a combination of the tools there, we run this test for each of our availability zones. Like I said before, we use a tiny instance. We use Syros because it's very small in size, so it's very quick to fetch that image and boot it. Because we don't want to create a lot of load on the other sites. We just want to make sure that the test is working. So it really helps us identify issues at the particular sites. It also helps us to identify when we have issues. We have central issues as well. So, if we notice that we start getting alerts that this test has failed at a couple of sites, we immediately start to look at the core and not the sites themselves. So it helps kind of take our focus away from the individual sites that have failed and start looking centrally. We also have a test that boots each of our different flavours that we offer. We've got a range of flavours from tiny, small, extra small, up to extra large. We can have interesting problems, due to our federation and due to the way that each of the sites operate slightly differently. Some flavours may fail due to scheduling or other issues. We use, you see the last point there, can be problematic with cells v1. So we operate with cells, which helps us scale across sites. Cells v1 is not recommended for use in production, but it was the only way that we could get the features that we wanted from our cloud. It helps us to scale in the way that we need. Cells v1 has scheduling within Nova, and Cells v1 can have problems. So by booting these separate flavors, we can understand if. So, for example, a real-world example we had was that one of the sites operates with SSDs in their hardware, whereas most of the sites have local spinning disks. And the SSDs, because it's smaller, there's not as much ephemeral storage. So we were having the issue where larger flavors that had ephemeral storage were being scheduled to that site, and then once they got to that site, their local scheduler would fail because they didn't actually have enough capacity. This is more of a cells issue, and generally most sites wouldn't have this kind of scheduling issue like we experienced. But by having this test, we were able to see that the smaller instances with smaller ephemeral disk worked fine, but the larger ones would fail. So that helped us identify, and looking through the logs, identify that the issue was due to this disk space issue, and we could fix that up with a disk filter. But having that test was really useful for identifying that problem. We also, this being able to test that the extra large flavors, we often hit resource limits. So we can, at the moment we're struggling to schedule extra large flavors due to the amount of resources they require. So being able to see this test go off helps us understand that that's an issue with us at the moment. So I talked a little about Tempest before. So it's the OpenStack integration testing suite. So the way that we use this through Jenkins is that we have a custom wrapper script, and we push the results passively to Nagios through RDP. We originally had Nagios sending a request to Jenkins and asking Jenkins to run our Tempest tests, but due to the way that worked, we were having timeouts because running a large flavour test might take 10 minutes, 20 minutes, depending on circumstances. We were getting timeouts. So we've written some code now, and what that code does is it allows us to run a job from within Jenkins. Jenkins will launch the Tempest test. Tempest test will run, and at the end of the Tempest test, it will call the NRDP endpoint through Nagios and push the results in. So it's a bit more flexible. It allows us to it just makes it better. I won't say any more about that. There's a lot more that we can do in this space too. At the moment, we're really only running the instance boot test. There's a lot more services that we could be testing as well, like Glance, Cinder, Swift. All of the sites run components of these, and the Tempest tests really go through the whole stack in their test, and so by having those tests, we could probably have a bit more confidence that they're working. So I think in the future we'll be looking at expanding some of these tests and maybe even writing our own Tempest scenario tests to extend those. This is a screenshot of Jenkins. You can see we've got, down the bottom part here, we've got a lot of our compute job tests. We've got the extra large here, that's red and stormy due to capacity. And we also have up the top here, this part is cleanup tests. We also use OS Purge. OS Purge is a tool for cleaning up resources within a tenant. We found occasionally, especially when you're having, if you're having issues, the Tempest tests don't always clean up the resources after them. So we run a little OS Purge test, which makes sure that everything gets cleaned up. Otherwise, we sometimes get quota issues. This is the Nagios view of the test. You can see for the extra large compute here, on the end there, no valid host was found, not enough hosts available. So the NRDP, the results being pushed in by NRDP. NRDP passes the result through Nagios, and Nagios, Nagios will then pull a result into here. And we've part of our sort of glue holding this together. We'll pass the final message that Tempest gives us, and we can pass that through the Nagios check here, so that when our sysadmins get the alert, they get the message and they can understand what the area is without having to go to Nagios and dig into it. They can see the message straight away. So this is what the users have access to. So on the right here, you've got you can see availability zones. So these are all our zones here, and the Tempest tests. The results of those go into Nagios, and then we've got some scripts there that then extract that data from Nagios, because Nagios manages it in quite a good way. I mean, it's a bit of a rough tool, but by writing some nice code around that, we can extract the metrics and show them on the dashboard here. So we can really provide the users with information that they can really use.
I mean,
Wilfred.
Phil point out some of the lower numbers on the right-hand side are due to a scheduled downtime, not unscheduled downtime.
Thank you, Wilfred. Yeah, definitely, it's all scheduled downtime. Yeah, on the left-hand side here, we've got Nagios testing the endpoints. So this will be testing the load balancer, and the load balancer would be load balancing requests across a whole range of APIs. So we can suffer some minor issues with the API hosts, and the load balancer will kind of cover that. So you can see they all look pretty good, 100%. So I talked a little bit about alerts. We configure everything through Puppet. We send our notifications from Nagios by email and Slack. Slack is a great tool. It allows us to have separate channels for our alerts. We can have admins at the sites subscribe to the channel that's suited to them, so they don't get a lot of noise. They can join or leave the channel as they wish to basically subscribe and unsubscribe from the alerts. It's very useful. Analysing logs is really important as well. It's not technically monitoring uptime, but we have an elk stack, so Elasticsearch, Logstash, and Kibana. It allows us to analyse the logs from the load balancer. So API requests come in, we can feed those in from the API hosts themselves, from the services. We can send those logs directly to a central server and analyse them. Generate some pretty dashboards, which help us pinpoint issues, especially if some services are running slow or we've got a really high number of requests. We can easily graph and see that in a nice, easy to digest fashion. There's an example of one of our graphs. We've got total requests here. It's a bit hard to read, but these are the separate services. We've got Nova. Nova's the purple one here. It gets most of the hits. We've got max response time, average response time. These are really useful when you've got issues, being able to kind of just have a glance at this, see what's going on, and really get a feel for what's happening without having to look too much. You've got all your traffic there. You can see it's purple's the Nova in that graph. You've got your average response times here. Nothing all that interesting going on there, which is great. That's exactly what we want. So tying it all together. So we use Puppet for building all the infrastructure. Puppet has some great stuff for integrating with Nagios. I won't speak too much about it, but we've got Nagios host and service resources that we can tie into our configuration that generates our Nagios config for us. We then, once the hosts are built, the config's stored in PuppetDB, and then we've got a tool that we've written called Naginator, which extracts that from the DB, and that generates our Nagios config. We also use Puppet to deploy Ganglia and set up our syslog shipping, and yeah, as I spoke about before, the custom scripts to extract the data from Nagios. And we generate the dashboard, and we can generate reports on uptime from there. So further work, we need more testing, test more services. We'd really like to generate alerts based on trends rather than Nagios's kind of okay, critical status. And also we really need to look at new tools. There's better ways to do this now. Prometheus is one tool that I'm interested in, but haven't had time to have a look into it yet. So that's it. Thanks for listening. That's our GitHub URL there. Some of these tools aren't on GitHub, I noticed. So if you're interested in anything, just get in contact with me, and happy to share the code. Thanks very much.
Thanks, Andy. Any questions for Andy?
I was going to ask you about your dashboard before you showed Kibana and the other based off Nagios.
This one or the other one?
Yeah, this one. So two questions actually, sorry. One is, given the scale of the environment and the complexity of the environment, I'm guessing you would get multiple alerts even a small sized environment like us gets hundreds of alerts every day. Have you built up sort of a workflow to fix some of the known, you can get an alert, match it against the database, create a workflow to fix it, which basically makes the whole thing automated, rather than having manual intervention every time you get an alert to fix it. I understand you can't fix everything, but some of the simpler ones can be easily fixed. That's one. Sorry. The second one is you suggested using Ganglia for metrics for CPU. And those can be really, really big and can be useful if you have proper dashboard to look at. So are you also pulling those data into Elasticstack? Or that's a separate sort of dashboard?
It is separate at the moment, yeah. I don't tend to look at, I'll answer your second question first. I don't tend to look at Ganglia that often. It's only really when things go wrong. I find this is a more useful display into really what's going on. And then from here you can kind of go, well, do I need to look at Nagios? Do I need to look at Ganglia? Or do I need to look at some other tool? So we kind of use each tool as its different purpose, and I think bringing them all together would be useful, but we haven't really had the need just yet. So for your first question, with a workflow for resolving issues, we haven't really had an issue to need to do that yet. When we get alerts, we generally try and stay on top of them and kind of fix the source of the issue. Right? Like if it's something that keeps reoccurring, well then we'll try and make sure that we implement something that fixes the root cause rather than sort of reactionary fix it when it comes up type thing. So yeah.
My question is, do you provide any support for the users themselves to run some sort of diagnosis when they face something wrong so that they can circumvent the problem before it's fixed? They will open, I guess they will open, when they face an issue, they open a ticket, but perhaps they could, say there is a site that is down for some reason, and they could use another site.
Like a self-service.
But if they don't know what's going on wrong, they might not, so they will need to wait the ticket to be fixed. Is there any sort of help or tools that the users themselves could use to get some idea of what's going on there?
I mean, apart from the dashboard that we provide them already, we don't really have anything. I think we have talked about implementing some way of having like messages and things like that appear in the dashboard, so that if we know that there's a network issue at a site, we could have like a ticker almost that says, "Don't use this site. We're currently having issues." We have talked about implementing something like that, but we haven't done anything about it yet. But I think it would be. I think it's an important tool that we have. Yeah.
We have a separate site, which is our distributed help desk, which if there's an issue that's going to be going on for a number of hours, there'll be.
We can post notices to our support site.
What he said.
Yeah, but I don't know if we've got visibility. There's not enough visibility of that, I don't think yet. But yeah.
We have time for one more question. We are eating into afternoon tea. So anyone else? Andy and Sam and others from the core services team are floating around if you have more detailed questions on all of this. So thank you, everyone, and looking forward to seeing you back here in half an hour for the remainder of the Innovation Education stream. Thanks.